There it is. Thank you. Okay. My name is Phil Murphy. I'm the CEO of a company called Cornelis Networks. For myself, I've got a long history in high-performance computing, going all the way back to the very, very beginning of the InfiniBand Trade Association. I was one of the founding members of the OpenIB consortium, which eventually became Open Fabric Alliance. I've been focused on high-performance computing, and the company is focused on high-performance computing. So let me just say a word or two about the company, because many of you may not be familiar with the company. But the company is an independent company now that's focused totally on providing high-performance scale-out interconnects to accelerate multiple different workloads, modeling and simulation, high-performance data analytics, and of course, deep learning environments. Okay. The company was established back in September of last year as a spin-out of Intel Corporation's Omni-Path division. This was the Intel High Performance Networking Group, and that all got established in September of last year. I often get asked a little bit about our name, so I'll just spend a few seconds letting you know. The name Cornelis Networks was inspired by a book that was very influential to me. It was a book written by Douglas Hostetler called Gödel Escher Bach, An Eternal Golden Braid. It was released back in the late 1970s. And it was a book that on the surface talked about these three characters, these three important figures, but in its essence was really laying the foundation for what intelligence was all about. And given our focus on artificial intelligence, we thought we'd give a shout out to that book. And the C in MC Escher stands for Cornelis, and that's how we came up with our name. Okay. So what markets are we focused on? Okay, well, as we probably have heard many times already, there are really three major workloads here that are very important to us, okay? And, we've always been focused as an interconnect provider on the modeling and simulation, the traditional high-performance computing marketplace. But even in that marketplace, we're seeing a trend towards increasingly adding deep learning type capabilities, right? So folks are able to analyze their code. They can see places where their algorithms can be enhanced by replacing, let's say, heavy-duty, double precision arithmetic with neural networks. They can get amazing speed ups at no or almost no loss of fidelity. Okay, and so this is all great. Okay, so these are the three markets: HPC, HPDA, and artificial intelligence. And what we're seeing from a lot of customers is that most of the organizations are running a wide variety of applications part-time, right? So if you're doing training all day, every day, you might not want a converged infrastructure. But if you're doing some artificial intelligence, but you're also doing a lot of other applications, then you definitely benefit from a converged infrastructure that's really great at handling all of these simultaneously. Okay. However, what that means is that the infrastructure itself has even more demands on it now from a variety of different directions. So what we've learned over time is that to really unlock the power of the compute infrastructure, you need a correspondingly powerful interconnect. That means very low latency. Okay, so that the communication amongst the nodes is as rapid as possible. But also you need a very high message injection rate throughout the entire network. Okay, highly scalable bandwidth becomes ever more important with artificial intelligence. There are other functions that are really critical to many application environments, things like collectors performance. Okay, all these things matter to the performance of the overall algorithms. And finally, it's very important to make sure that we use the fabric very, very efficiently. And we characterize it under a broad label called optimized data flow. We'll get into what that means a little bit more in a few seconds. But this is our company. The company is focused on delivering a total end-to-end solution for high-performance interconnects. It's built on a foundation of over 20 years of taking the best of InfiniBand, taking the best of other technologies, such as technologies that we inherited from work that created many years ago, taking the best of all this, putting it together, and evolving it towards the future. So we're very excited about our capability and what we can bring to the marketplace. Okay, so I just want to give you a quick view of what our roadmap looks like, and I'll get into some of the technological details. But today we are shipping our existing solutions called Omni-Path, okay, and they've been in the market for a couple of years now. But in the fall, we're introducing a significant enhancement to that product, which we're calling Omnipath Express. And I'll spend a few minutes talking about it, but we're very excited because we're seeing dramatic improvements in two dimensions. The first dimension is just incredibly enhanced performance. We believe it's going to be the industry-leading performance across all of the key metrics that are associated with high-performance interconnects. Also, we're extending the breadth of the capabilities dramatically as well. I'll get into that in a minute. The rest of our team, though, was working on the next generation of capabilities, and that would include our 400 gigabit per second products, which we're expecting to be introducing in late 2022, with full capabilities in the first quarter of 2023. We're also looking beyond that into the next generation beyond that, our 800 gigabit per second solutions. There's lots of different ways we can go. We're evaluating all the trade-offs between cost and performance, optics versus copper, going wide or going more narrow. All those things are being evaluated as well. So we have a very robust roadmap. You're going to see the first shiny new products from us coming out in just a couple of months. And then you'll see us on quite a cadence going forward. Okay, so that's a quick view of what our roadmap looks like. And we're an independent company. We're supporting all the different CPU and GPUs out in the industry. We're also supporting all the different operating environments. And so it gives us great strength. So I'd like to talk to you a little bit next about Omnipath Express, okay? And what's going on here is that Omnipath Express is powered by a new highly optimized host software that supports Open Fabrics interfaces, okay? So what's been going on in our industry here for quite some time is that you can see a kind of a picture of a software stack here. When InfiniBand was first being defined and we were heavily involved in all of that, it was really focused on a different market. It was focused on enhancing the storage market, frankly, right? So it was kind of replacing the channel architecture and servers. And that's what Verbs was all about. And we saw some IO-focused upper layer protocols and file systems running on that. It's all doing very well. There's another company, though, that came into play a little bit later called Pascal. And they recognized that there was a way to use InfiniBand for high-performance computing, but you needed a different transport layer, and they created PSM. Okay, and so upper layer protocols, the MPI protocols, OpenMPI and Mvapage, for example, have been ported to PSM2, and wow, we got much better performance than anything based on Verbs and much better scalability. However, even that is now 20 years old, okay? And so what's been happening over time is, as everybody knows, node architectures continue to evolve. Okay, they're no longer just a couple of CPU sockets. Now we have CPU sockets surrounded by accelerators. We also have a wider range of application environments, not just modeling and simulation, but data analytics, artificial intelligence, object file systems, all sorts of things that we have to support. And so the industry recognized this a long time ago and said, you know what, the correct answer here is to take all these new modern requirements, take the best of what was out there already, understand where nodes are going, understand where application environments are going, and create this Open Fabrics interfaces. What we've done is we've created a native Open Fabric interfaces provider driver, okay, that gives us just phenomenal performance. And not just phenomenal performance, but also allows us to support a much broader range of application environments. So not just all the common MPIs, but also we're able to support PGAS programming models using SHMEM and Chapel. We're able to support additional AI frameworks such as TensorFlow and PyTorch, object storage files, and even generic support for GPUs. Okay, so that's why we're really excited about it. And so this is sort of another kind of view of our roadmap, just to be clear, right? We are an end-to-end solution provider, which means all the software, all the hardware required to deliver an end-to-end solution. This would include the adapters, the edge switches, the director class switches, all the cables, and the gateways required to bridge to other types of fabrics. We are and are continuing to ship the existing Omni-Path technology that's been in the market for a while. We're giving it a significant refresh coming up in November. We'll be announcing it in conjunction with a supercomputer event in November. And then we're coming out with our next generation 400 gig solutions in 22. Okay. So that's another kind of quick glimpse of our roadmap. Here's some of the reasons why we're very excited about Omnipath Express. Okay, and so I'm going to start just by showing one of the key metrics, which is latency. And of course, we always measure latency at the MPI level. So this is not at any lower level, which you might see in other presentations. But this is running the OSU MPI ping pong test. Okay, and what you're seeing here is that we have driven our what we consider to be the industry leading latency through a switch hop down another 12% on average, with some of it even more significant, focused on small message performance. Okay, that's one of the things we focus on. But we also focus on software footprint, which I'll talk about in a second, and message rate, which I'll also cover. Okay, and so let's talk about software footprint next. Okay, software footprint to me means several things. It means one, minimizing the amount of time that you're actually spending on the CPU running networking software. Okay, so CPU utilization, but also related items like are you trashing the CPU cache so that when the control returns to the application, the data is still there? Are you trashing the TLBs, things like that? So to get the maximum compute and communication overlap, you need to make sure that you have the minimum software footprint. We've done that as well. Okay. And then finally, message rate, right? And this is really just kind of makes it very clear what's going on here. We dramatically be able to increase our message rate as well. We're hitting the theoretical maximum messages per second, almost at 350 million messages per second across two Xeons talking across a single switch hop. So dramatic improvements in performance. Okay, and that was all cores talking to all cores, single core. At the time that we showed this, we're approaching 8 million messages per second on an Intel Xeon. We've actually significantly eclipsed that in our experimental code, so we're continuing to see just phenomenal performance there. A very similar story with AMD. When we were previously part of Intel, and we focused on Intel processors, now we've expanded our support for AMD as well, and we're seeing just fantastic message rate improvements. The red bars are now what we're getting in Omnipath Express to be coming out in the market in November. Okay. We're also seeing great latency improvements on AMD as well. As you can see here, we've seen some cases where the latency dropped to almost 30% on small messages. And these are the main predictors of application performance in the long term. The average reduction in latency across the small messages was 16%. Okay, and one of the things that we're really proud of is our collectives performance. We have worked with the industry to make sure that we understand what the algorithms are and to make sure that those algorithms take maximum advantage of our capabilities. And so we have the best collectives performance in the industry. We would love to compare this with anything else out there, but you can see that we have just phenomenal flat latency across 16 nodes, 64 processors per node across a very wide range of message sizes. So kind of in summary for all this, the idea here is that we are able now to embrace this new technology that's really been in the development by the industry since 6 or 7 years now, called Open Fabrics Interfaces, putting the right provider driver in place that unlocks performance and all of the other capabilities that I talked about. In my short remaining time here, I just want to give you a quick glimpse into what we're doing in the future, okay, what we're focused on, which we think are the most important aspects of next generation interconnects, okay? And it really breaks into two major categories. One is making sure that we have the optimized host interface, okay, the hardware and software that creates the best semantic match for what modern applications need into the next generation fabric. And so, we're focused on what we call an OFI adapter, okay? In the past, people might have been focused on other things like portals adapters, for example. This is a much better solution. It takes advantage of the acceleration capabilities that the industry's been working on for the last 5 or 6 years. The rest of what we're focused on is making sure that we have the most efficient fabric to move the data between nodes, okay? And so supporting various topologies, for example, not just trees, but dragonflies, megaflies, HyperX, for example, are all very important to have low latency, low hop count fabrics. Of course, they require significantly advanced routing algorithms to make sure that they work effectively. Then we make sure that we have the lowest latency possible. We make sure that we don't put anything in front of our ports. For example, Ethernet gateways that might slow them down. We make sure that we actually have the absolute minimum latency. As I mentioned way back in the beginning, some of this technology was born from technology that Intel had acquired from QLogic and from Cray, and that technology that we integrated actually makes sure that we have the right bit on the wire at the right time all the time. Okay, and so that gives us advantages over any other technology out there. Then we have to make sure that we avoid congestion. And there's really a couple different kinds of congestion that we can be talking about. One is very instantaneous congestion that is there for a short period of time and then clears. That kind of congestion, the only way to deal with that, as far as we can tell, is to make sure that there is excellent quality service, to make sure that the most important application gets the bandwidth and gets the access to the fabric in priority, okay? And the second thing is just to make sure that you can preempt packets that shouldn't have been on the wire, and that's a really big, important improvement that we've got in our adaptive routing. And then the final piece here is, what about cases where you have long-standing congestion? For example, you have an incast problem where you have many senders sending to one receiver. How do you resolve that problem? The answer to that question is there's only one known solution, that is to back off the senders. We've got patents going now on just a phenomenal improvement in how to make sure that you avoid congestion with no impact to the rest of the fabric. Okay, so yeah, that's our quick story here. I'd just like to summarize in a few seconds here that we are an independent company now, spun out of Intel back in September. We're focused on delivering an end-to-end solution for scale interconnects to address modeling and simulation, as well as data analytics and artificial intelligence, specifically deep learning. Okay, we are co-optimized for a wide variety of compute devices, processors, and accelerators, and I shared a little bit of that data with you. We are, as a company, committed to open standards. Okay, so we are working with the Open Fabric Alliance. We have adopted Open Fabric's interfaces. We are committed to continuing with such open standards. And we'd love you to test us out, because we do believe that even today, at this minute, we're delivering the best performance and by far the best price performance in the industry for MPI and other MVAPs and other MPIs, but also you're going to see shortly extended capabilities around PGAS, AI frameworks, object storage systems, and other accelerators. The other thing to point out is we're really investing heavily in next generation solutions that will increase port bandwidth and have application-specific but scalable accelerators. Very important to deliver scalable accelerators, as opposed to trying to kind of offload some processing to let's say, a small microprocessor that could certainly not handle the burden. Okay, and so in summary, I think that we can demonstrate the highest performance and by far best price performance for converged infrastructure in the industry. And that's it.
Thank you, Phil. I think we have questions. If you can make time to look at. The first question is, are you impacted by the chip shortage we keep hearing about? And the second question is about extended, long-distance physical range InfiniBand. Answer those, that'll be thank you.
Right. So let me talk a little bit about the chip shortage first. Right. So look, we know that there's a worldwide chip shortage, and it's really impacting everyone. One of the things that we're able to do, though, as we were coming out of Intel, is we were able to strike a deal with Intel to procure a significant amount of inventory. Okay. And so and then on top of that, we were also able to buy ahead, and so that we could make sure that we had supply. And so we have fantastic supply going forward. We're shipping now with lead times of 2 to 4 weeks right now, and it's really exciting. And we're keeping on top of it. Okay, we're doing things like going out to the markets to make sure that we're sometimes to the merchant markets to make sure that we have all the components that we need, because it's not just the main ASICs, but it's across the board everything is sort of being rationed. Okay, but I can assure you right now that because of our careful planning, we have significant supply and are shipping in very short order. I think the second question was around extension technology. We are developing extension technology right now. I mentioned that we have a set of gateways to start with. Okay, those gateways are able to extend our fabrics to really any length. And I probably don't have time to get into, but we do have other technologies that we're working on in parallel.